Welcome to the Chemistry, Biology and Math Revision Hub. Today we are doing the Pearson Edexcel International A Chemistry Unit 2 potential questions for any Unit 2 exam. Let's begin with the first topic. Topic 6, Energetics. Here they can ask you about enthalpy change and enthalpy level diagrams. You need to know about exothermic and endothermic reactions, standard conditions which are 298 Kelvin, 100 kilopascals, and so on. They can ask you about definitions for standard enthalpy change or enthalpy changes of reaction. You need to know combustion, formation, and so on. You need to learn how to draw and label enthalpy level diagrams for specific reactions. Here they can give you a specific reaction and ask you to place the reactants as well as the products around the enthalpy level diagram. Remember, the vertical axis is enthalpy. The horizontal axis, you can name it or you can leave it, but I always prefer it's labeled progress of the reaction. They can ask you about experiments, and here they'll talk about experimental setups and descriptions or describing the procedure for the enthalpy change of combustion. You need to remember the whole setup. You may not be required to draw, but you could be required to talk about it or to describe what happens. You need to learn how to calculate for enthalpy change of combustion, including the assumptions that are made. You need to know about the sources of error as well as the calculations. So in this case, heat losses, incomplete combustion, and loss of fuel. You need to learn to describe the setup and the procedure for the enthalpy change of neutralization. In this case, remember the acid is mixed with the alkali and then a reaction goes on. How are you going to determine the mass that is going to be used to calculate the Q? You need to remember all that. You need to know how to calculate and make assumptions for enthalpy change of neutralization. And then lastly, you need to know how to find the sources of errors in calculations. Most of the time, errors are going to be in experimentations whereby there is going to be heat losses, so you need to be able to write that down. Moving on to Hess law, you need to know the definition for enthalpy change of formation. You need to try calculations involving Hess law because these are very common. So to do that, ensure that you can fully calculate question 1, 2, and 3 on page 159 because many students found question 3 kind of hard. You need to know about bond enthalpies and the mean bond enthalpies, using mean bond enthalpies to calculate enthalpy change of a reaction, and then the limitations for using mean bond enthalpies. Remember, they are usually calculated for substances in the gaseous state. If you use them in a different state, like in solid state or in liquid state, they could cause some errors. You also need to know about standard enthalpy change of atomization and the calculations around that. Use a lot of past paper questions in order to help you practice that. Moving on to topic 7. Topic 7, intermolecular forces of attraction. You need to remember descriptions or describing how London forces arise. You need to know about permanent dipoles. And then you need to know about hydrogen bonds. And for hydrogen bonds, we know that the bond between fluorine and hydrogen is greater than the intermolecular force of attraction between hydrogen and oxygen, which is greater than the intermolecular force of attraction between hydrogen and nitrogen. You need to learn how to draw intermolecular hydrogen bonds in water molecules, ammonia, as well as hydrogen fluoride, and when you do so, ensure the bond angle remains 180 degrees. Intermolecular forces and physical properties of molecules. They can ask you about explanations in terms of intermolecular forces for the differences between boiling points of molecules. Here you need to remember that branching decreases boiling points because the points of contact between the molecules are going to be lowered. They could ask you about explanations for why alcohols have higher boiling points than equivalent alkanes. Of course, equivalent alkanes are going to have the same number of electrons as the alcohols. So the only reason as to why alcohols should have a higher boiling point is because they have permanent dipoles as well as intermolecular hydrogen bonds. You need to learn to sketch the graph of boiling temperature of hydrogen halides. You remember it's shown on page 176. In this case, you need to know that hydrogen fluoride is going to have a very high boiling point, and then we come down. Among the other remaining 3, hydrogen chloride is going to have the lowest, and then hydrogen bromide, and the highest among the other 3 is going to be hydrogen iodide because the London forces are going to increase in that train due to the increase in the number of electrons. You need to know about the anomalous properties of water, learn to explain why water has a higher boiling point even though it has fewer electrons. Of course, that is going to be due to formation of intermolecular hydrogen bonds, and one water molecule can form intermolecular hydrogen bonds with 4 other water molecules. You need to learn to explain why the density of ice is less than the density of water at 0 degrees. Solubility of compounds. Here you need to learn to describe how ionic compounds dissolve in water in terms of hydration energy. Remember, hydration energy is the exothermic energy released when water molecules surround ionic compounds. So that is going to be used in the dissolution of the ionic compounds by pulling them apart. You need to simply understand about choice of solvents, why alcohols are preferred as solvents in reactions with halogenoalkanes than using water as a solvent. So moving on to topic 8. Topic 8, redox chemistry and groups 1, 2, and 7. They'll ask about oxidation numbers and redox equations, so you need to learn to differentiate oxidation and reduction reactions. You need to learn the meaning and examples of disproportionation reactions. Learn to calculate the oxidation numbers on page 187 and recognize redox numbers based on oxidation states. You need to learn to name compounds based on oxidation numbers, and you need to learn to construct half equations as well as full ionic equations from given information. When we go to trends in group 1 and 2, they'll ask you to explain the trends in ionization energy, of course, first and second ionization energy. This is in reference to the nuclear charge, the orbitals, as well as the shielding effect. They'll ask you to explain the trends in reactivity. An example is where reactivity increases as you go down the group. And again, you could explain this in terms of nuclear charge, shielding effect, as well as the size of the atom or the number of orbitals that exist. The next part is reactions of group 1 and 2. Reactions with oxygen to form oxides, you need to know that. Do not forget about the observations for that. Reactions with chlorine to form chlorides, of course, that you need to know as well. Reactions of group 1 and group 2 with water. When they react with hot water, you need to remember that they produce oxides, and when they react with cold water, you need to remember that they produce hydroxides. You need to remember the observations made during these reactions. When we go to trends of group 2 hydroxides and sulfates, you need to know the trends in solubility. Solubility of group 2 hydroxides, you need to remember that this increases as you go down the group. Magnesium hydroxide is insoluble, while barium hydroxide is soluble. You need to remember that using lime water, which is calcium hydroxide, is carried out to test for the presence of carbon dioxide. And then you need to remember that magnesium hydroxide can be used as an antacid because it neutralizes the acid in the stomach. You need to know that barium hydroxide is used in barium mills, in hospitals for X-ray imaging. When we go to thermostability of group 1 and 2 carbonates as well as nitrates, you need to remember the factors affecting thermostability, including ionic radius, ionic charge, as well as polarization. You need to fully understand this because this can be detailed, and this comes in section A as well as the other sections. You need to remember that lithium nitrate and all the other group 2 nitrates decompose to form oxygen, nitrogen dioxide, which is brown, as well as oxides. Also, you need to remember that other group 1 nitrates, meaning not lithium nitrates, when they decompose, they form nitrites as well as oxygen. You need to remember that lithium carbonate and the other group 2 carbonates decompose to form oxides and carbon dioxide, while other group 1 carbonates do not decompose, at least at lab conditions. You need to remember to write balanced equations for these decomposition reactions, and you remember to draw the apparatus used for thermodecomposition. So position the test tube properly, and then the sample is going to be inside. There is a Bunsen flame, and then you have something you use to hold the test tube that can be well demonstrated. This is common in Unit 3. They could ask you about flame tests, so please remember to describe how a flame test is carried out. This question again is very common in Unit 3. They can also ask you both in Unit 2 and Unit 3 to explain the origin of color in a flame. You need to remember the observed color in a flame test with lithium cation, sodium cation, potassium cation, cesium, rubidium, beryllium, magnesium, calcium, strontium, as well as barium ions. You need to state the test for ammonium cation. You remember the test for presence of ammonium, add sodium hydroxide and warm, and then a gas is going to come off that you can test with litmus paper. But this litmus paper has to be damp and it has to be red because the gas is ammonia. The damp red litmus paper is going to turn blue. Trends in group 7. They can ask you explanations for the trends in boiling and melting points. Please remember they increase due to London forces, and that is due to the increase in the number of electrons as you go down the group. They can ask you about explanations for trends in electronegativity among halogens, like nuclear charge, interatomic distance, the shielding effect, and so on. And lastly here, they can ask about trends in reactivity. Remember, halogens react by gaining electrons, so fluorine is going to be the most reactive one because it's smaller in size and it will gain electrons faster in comparison to iodine, which is really big. Next part is redox reactions in group 7. These are very common and they could be attached to unit 3, but they can also be very common in unit 2. So please revisit displacement reactions among halogens. Remember that those above the group replace the ones below them in the compound. You need to know about disproportionation reactions among halogens, like when chlorine reacts with water, it produces HCl, oxidation state -1, and HClO, oxidation state +1. Chlorine also reacts with cold alkali, like potassium hydroxide or sodium hydroxide, to produce sodium chloride, which is going to be -1, and an HClO, which is +1, as well as water. Chlorine can also react with hot alkali, again potassium hydroxide or sodium hydroxide, to form compounds in -1 and +5 oxidation states. They can ask about reactions of halides with sulfuric acid. These are very common. They can come in Unit 2 as well as Unit 3. So remember the reactions and the equations that produce hydrogen sulfate ions. Remember, for production of hydrogen sulfate, these are not going to be redox. However, there are other redox reactions as shown in Table B on page 214. So remember those reactions, 214 as well as 215. In the table, they show the products, but the reactions are on page 214 and 215. So remember the observations when these halides react with sulfuric acid. Remember to write the ionic equation for these reactions. When we go to titration, remember that apparatus and describing the procedure for making a standard solution. You also need to remember indicators used and their endpoint color changes in a titration. You need to know that methyl orange in acid is going to be red, and in the alkali is going to be yellow, and phenolphthalein is going to be colorless in acid, and it's going to be pink in alkali. These two indicators are going to be very common. This also comes in Unit 3 because there is usually a titration question. You need to remember how to find concordant results in a titration, and remember the difference between errors and mistakes. They are systemic errors, they are also random errors. You need to learn about measurement uncertainties in balances, burettes, pipettes, and volumetric flasks. This is common as well. You also need to practice calculating the percentage uncertainty in these calculations. Moving on to topic 9. Topic 9, Introduction to Kinetics and Equilibria. You need to learn about the collision theory, where we know the rate of a reaction can be calculated from the concentration time graph by finding the gradient. You need to measure the change in concentration or change in volume of a gas within a specific time in order to calculate the rate. You need to know that for a reaction to occur, reactants must collide with the right energy, which we call activation energy, as well as the right orientation for a successful collision to occur. They can ask you about factors affecting the rate of a reaction. Remember temperature and how it affects. Higher temperature leads to a higher kinetic energy that increases the energy the particles possess, so now they can collide with energy equal to or greater than activation energy for successful collision. Remember how changing concentration affects the rate of a reaction, how changing pressure affects the rate of reaction. This is mainly for gases. You need to know how adding a catalyst affects the rate of a reaction. Of course, it's going to increase the rate because it creates a new pathway with lower activation energy, and then there are more particles that are reacting. How surface area for solids or increasing the surface area for solids affects the rate of a reaction. You need to focus a lot on the Maxwell-Boltzmann distribution curves in terms of temperature as well as changing the activation energy. Those two are very common. You need to know the shape of the one for lower as well as the one for higher temperature and how you can draw both of them on the same graph. Focus on using Maxwell-Boltzmann distribution curves to explain the effect of a catalyst. You need to ensure that you can show the catalyzed and the uncatalyzed regions. You need to know the effect of catalysts on reaction profile diagrams, as well as catalysts in industry. Here, focus a lot on the equations of iodide and peroxide sulfate. They could ask you why these reactions proceed slowly if the catalyst is not added. Remember that iodide as well as peroxide sulfate are both negatively charged, so they will repel each other. That is why the reaction proceeds slowly. However, when you add a catalyst, which could be iron 3 plus or iron 2 plus, then the reaction could proceed faster. When we go to dynamic equilibria and reversible reactions, you need to know about the forward and the backward reaction rates. They are going to be equal at dynamic equilibrium. You need to know that at dynamic equilibrium, the concentration of the reactants and the concentration of the products do not change. Please, this does not say that the concentration terms are equal. They do not change. Also, you need to remember to sketch a graph to show the dynamic equilibria as showed by in figure A on page 247. When we go to factors affecting equilibrium reactions, of course here we're going to focus on temperature, pressure, concentration, as well as adding a catalyst. For temperature, if the endothermic as well as exothermic forward reaction, how it's going to be affected whether temperature is increased or decreased. So you need to know how the effect on endothermic as well as exothermic forward or backward reactions, how they're going to be affected. You need to know for pressure, if you increase or decrease the pressure, how is it going to affect the position of equilibrium? And if you increase the concentration either of the reactant or you remove the concentration of a reactant or products, how is that going to affect the position of equilibrium? Looking at catalysts, catalysts have no effect on the position of equilibrium, so you need to know that. Lastly, from topic 9, reversible reactions in industry. They could bring questions asking why specific industrial conditions are used, like a higher temperature can be used even for exothermic forward reactions to increase the rate of reaction, and this can lead to a lower yield but a higher rate. So it is a compromise, of course, between yield and rate. So the manufacturer wants to get the products in a shorter period of time, so they compromise by using a higher temperature, even if the higher temperature decreases the yield of the product because it shifts equilibrium to the left. They are ready to do that in order to obtain the products in a shorter period of time. This is usually attached to questions that are 6 marks, asking you specific conditions and why they are done in industry in case of using what could make sense. Why do they use a higher temperature for a reversible reaction if the forward reaction is exothermic? They could ask about a higher pressure and why it's used. A higher pressure can be used to shift equilibrium to the product side, and a catalyst can be used so the reaction proceeds at a lower activation energy. Please remember iron as a catalyst in the Haber process, and also vanadium is used as a catalyst. So this is vanadium pentoxide or vanadium 5 oxide is used as a catalyst in the contact process for the formation of sulfur trioxide in the process of formation of sulfuric acid. Topic 10, halogenoalkanes, alcohols and spectra. Here they can ask you about reactions like addition reactions, elimination reactions like those converting halogenoalkanes to alkenes, substitution reactions like among halogenoalkanes, oxidation reactions like how alcohols can be converted into carboxylic acids, reduction using hydrogen in the presence of nickel, and alkenes are reacted in that manner. And then you need to remember reaction mechanisms can be free radical substitution reactions, electrophilic addition reactions, and nucleophilic substitution reactions. They can talk about halogenoalkanes as being primary, secondary, or tertiary. A common question is about rates of hydrolysis among halogenoalkanes. Here, ethanol is used as a solvent, and silver nitrate is added, and the precipitate formed is going to be observed. Here, they observe which precipitate forms first. Is it a chloro, a bromo, or an iodo, because they have different colors. You need to know why iodobutane reacts the fastest and chlorobutane reacts the slowest. Remember, both iodobutane and chlorobutane are primary halogenoalkanes. So among primary halogenoalkanes, why is the iodo reacting faster? That is because the bond is the weakest. They can also ask you about tertiary halogenoalkanes reacting faster than primary halogenoalkanes. This is because of inductive effect causing the tertiary halide to break off faster, so its precipitate is going to be detected. They can ask about mechanisms of halogenoalkanes, like substitution, for example, with water, with potassium hydroxide, with KCN, and with ammonia in a cell tube. You need to be able to write the products, these equations, as well as the products formed. And in some cases, they can ask about mechanisms. Like in a reaction with ammonia, you could draw the mechanism. They could also ask about elimination reactions. Of course, you're not required to write this mechanism, but you need to know that halogenoalkanes can react with potassium hydroxide in alcoholic conditions, and an alkane is going to be formed. This is a very common question as well. When we go to alcohols, know that they can be primary, secondary, or tertiary. And then you need to know the reactions as well as the conditions that alcohols go through. They can go through combustion, which can be complete or incomplete. They can go through conversions to halogenoalkanes. When you want to form chloroalkanes, you will react with PCl5 if the alcohol is primary or secondary. If it's tertiary, you could directly react with concentrated hydrochloric acid. And for bromoalkanes, you can react with a mixture of potassium bromide and sulfuric acid. This is going to produce HBr, which is basically the reactant. For iodoalkanes, use phosphorus in the presence of iodine. And for alcohols, you need to remember about dehydration to alkenes using phosphoric acid. Going to oxidation of alcohols, this is as well common in Unit 2 as well as Unit 3. Primary alcohols can be oxidized to aldehydes, and if you want to get a product here, you need to use acidified potassium dichromate and distill off the product. For primary alcohols to be converted to carboxylic acids, you need to use acidified potassium dichromate, heat under reflux. They can actually ask you, why do we heat under reflux? You need to know that. And then for secondary alcohols to ketones, use the same reagent, acidified potassium dichromate, and heat under reflux. Please remember the color changes for these oxidation reactions because dichromate is going to be orange and it's going to be converted from orange to green. You need to draw and label apparatus used for distillation as well as heating under reflux. When we go to purification of organic liquids, you need to remember the apparatus used. Here they can talk about the details of simple or fractional distillation. You need to fully understand the details of solvent extraction using a separating funnel. Please remember revisit the whole detailed explanation and description because it can be asked. This is usually a Unit 3 question. They'll ask you the details of drying organic solvents. You need to include the possible drying agents, and please remember when you're writing their names you have to put anhydrous before each one. You need to learn about testing for purity of organic liquids. In this case, of course, we carry out boiling point determination. The next part is details of mass spectrometry. Here you need to remember this as well, common in Unit 3. They can talk about the molecular ion peak, the M+1 peak, as well as molecular mass. Please remember about fragmentation patterns and remember the mass to Z ratios of 15, 28, 29, as well as 58. Please do not forget the pattern at 31 mass to charge because this is very crucial. This corresponds to the CH2OH plus fragment. This is very common most of our alcohols, please remember, at mass to charge 31. Then practice with past papers to fully understand this fragmentation. Lastly, we talk about infrared spectra. You need to practice drawing displayed formulae to visualize bonds present in these molecules, like when the OH is present or the carbon-carbon is present, the carbon-carbon double bond, and so on. In practice with past papers and wave number data to perfect this topic. These questions can come or they could bring common questions about aldehydes and ketones. They have the same molecular formula, but the structures are different, so they could ask you to compare them in terms of infrared spectra. So this brings us to the end of this video, as well as the end to potential questions from Unit 2. Thank you for being with us. Do not forget to subscribe. See you in the next video. Bye-bye.